Trigonometry is made up of three Greek words, that is trigon and metron, which is three sides measurement. We know that a three-sided figure is a triangle, but trigonometry is specifically defined for the right angle triangle. Here in this figure it is a right angle triangle which is right angle at B. So the side opposite to the right angle is known as hypotenuse and it is the longest side. But these two sides can be changed according to the concerned angle. For example, I have taken this angle C as theta. So the side opposite to this theta angle will be known as perpendicular, and the side over which it is forming is known as base. But if we take this angle 90 minus theta, then the side opposite to this is BC. Now this will be the perpendicular and this will be the base. Trigonometric functions, these are the relationship between sides and angles of a triangle. There are 6 functions defined, which are known as sine, cos, tan, cosec, sec and cot. Sine of any angle theta can be given as perpendicular upon hypotenuse. So perpendicular in this case is AB and hypotenuse is AC. So sin theta is AB upon AC. Similar way, cos is defined as base upon hypotenuse. So base is BC and hypotenuse is AC. So cos theta is BC upon AC. Tan theta is defined as perpendicular upon base. Perpendicular is AB and base is BC. Cosec theta can be given as 1 upon sin theta. So it will give the value of AC upon AB. Sec theta is 1 upon cosec theta. So it will become AC upon BC, and 1 upon tan theta is cot theta. So if you know the angle of, if you know just one angle and one side, so you can calculate other sides of a right angle triangle with the help of trigonometric ratios. Now if I want to calculate the complement of this theta, which is 90 minus theta, so I am calculating the sine of this 90 minus theta. So in this case the perpendicular will be BC and hypotenuse is AC. So the sine will be BC upon AC, which is equal to the cos theta. So the complement sine 90 minus theta is equal to the cos theta. Now let us calculate the value of sine 45 degree. I have taken a right angle triangle in which two acute angles are equal and they are 45 each. If two angles are equal, then side opposite to them will also be equal. Suppose I have taken the value of side as A. Now let us calculate the hypotenuse of this right angle. So hypotenuse can be calculated by the Pythagoras theorem. It states that hypotenuse square is equal to perpendicular square plus base square. Perpendicular is A and base is also A. So A square plus A square will give you 2A square. Now taking the square root, so hypotenuse is AC and it will come out root 2A. Now sine 45 is perpendicular upon hypotenuse. So perpendicular is AB and hypotenuse is AC, which is A upon root 2A, and it will come out to 1 upon root 2. Similar way, cos 45 is base upon hypotenuse. Sorry. So it will give the value of A by root 2A and it will come out to be 1 by root 2. And tan 45 is perpendicular upon base, which is both A and A. So tan 45 is 1. Now let us see the values of trigonometric ratios for some specific angles. A table can be devised for these angles, which are 0, 30, 45, 60 and 90. But I am telling you a way in which you can you don't have to cram this table and you can write it down by your own. So first form a table in this manner and write the value from 0 to 4 in a row. So 0, 1, 2, 3, 4. Next step, you will divide the whole row by 4. So 0 by 4, 1 by 4, 2 by 4 and so on. And the third step will be you have to take the square root of the whole row. So square root of 0 upon 4 is 0, 1 by 4 will give you 1 by 2, 1 by 2, 2 by 4 will give you 1 by root 2, 3 by 4 is root 3 by 2 and 4 by 4 is 1. Square root of 4 by 4 is 1. Now sin 0 will take the value of 0, sin 30 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2 and sin 90 1. For cos theta, you have to just reverse the value of this row. So cos will take all the values of 0 to 90. So here I have reversing the row. So this 1 root 3 by 2 here, 1 by root 2 here and 1 by 2 here, and this is 0. Now tan theta can be calculated as sin theta upon cos theta. So 0 by 0, 0 upon 0, 0. 1 by root 2 and upon 3 by root 2 will become 1 by root 3 and so on. But 1 by 0 is not defined because if you get 0 in the denominator, then that term is not defined. and cos theta you can calculate as 1 upon sin theta, and similarly sec theta is 1 upon cos theta, and tan theta is 1 upon cot theta. So you can form the whole table. Just note down one thing, that the minimum value of sine is 0, and it is 0 for 0 degree angle, and the maximum value is 1, and it is for the 90 degree angle. So the value of sine is fluctuating between 0 and 1 for 0 to 90 degree angles, and cos theta's value are opposite to the sine, that the maximum value of cos is for 0 and minimum value is for 90. Now let us know how to make trigonometric identities. Here it is a right angle triangle, and I have write the Pythagoras theorem. So AC square is equal to AB square plus BC square. So if I divide the whole equation by AC square, then I will get the equation in this form. Here AC and AC will be cancelled out, and AB upon AC is perpendicular upon hypotenuse, which is sin theta. So here sin theta, and BC upon AC is nothing but base upon hypotenuse, which is cos theta. So I get the identity in the form sin square theta plus cos square theta is equal to 1. So in similar manner, I can make the other two identities by dividing in the next step by AB square. So I will get the identity 1 plus tan square is equal to sec square theta, and if I divide it by BC square, this equation, the whole equation by BC square, then I can get the other identity as cot square theta plus 1 is equal to cosec square theta. So these are the three trigonometric identities I can devise by this right angle triangle.